Hello everyone. Um, I'm going to talk about Jsonrpc implementation that we did in OVIR. So, brief agenda. Um, I will be talking about motivation and why we made that change. As well, I will give you more details about the protocol itself, why we decided to use particular protocol, and how the messages looks like. Later on, I will focus on engine implementation. I'll give you details how the implementation looks like, as well how to extend the API. The next thing that I'm going to cover is VDSM implementation. I will give you the brief overview how the protocol changes are implemented. As well, I will tell you how to extend the API. I'm going to cover as well the flow, exactly how the messages pass between engine and VDSM, and later on we'll tell you more about future plans for the protocol changes. So let's start. We have decided to use JSON over the XML since we find it better and faster for our needs. As well, it's more human readable. Um, the change that we wanted to actually achieve, which will enable us later on to implement further functionality that we are willing to have, is the asynchronicity of the communication. um, the, uh, the the difference is that instead of waiting on a response from VDSM, we are just being notified about response when it's there, and we can leverage that. I will cover that more in detail when we'll talk about the flow. The implementation that we used before xmlrpc was really tied to the specific xmlrpc. Right now, the abstractions are created in that way that it's really easy to add additional protocols without changing the API. So right now we can introduce another protocol, and I will talk about that later on, without changing the API and recompiling. What we want to achieve by having the asynchronous communication and being agnostic in terms of protocol, all of you know that we are polling for long-lasting tasks for VDSM, and as a part of that, the goal is to have push instead of pull. So whenever something changes on VDSM side, the VDSM can actually push those changes to the engine. So that will enable us in big environments to have better performance. Let's move on to differences between the implementations. So the biggest difference that we introduced during with the Jsonrpc is the communication maintenance. So that means that we have the communication open all the time, and the messages are sent back and forth between the engine and VDSM. Because of the known flows like maintenance and reboots of VDSM, we just need to be sure that the open channel is not stale. And the mechanism to make sure that the channel is not stale is the heartbeats. We implemented heartbeats on top of the STOM protocol. I will talk about the protocol itself later. So as a during the initiation of the connection, there's negotiation of the timeouts between the heartbeats that will be sent back and forth. In current implementation, the heartbeats are sent only for VDSM, from VDSM, since we are keeping the model that the engine is talking to VDSM in this phase. So so the other side heartbeats are not needed. Once we introduce the pushes from VDSM, we'll as well implement the heartbeats from the other side. One of the biggest differences as well is move from HTTP to TCP. As you all may know, engine used to use HTTP client from Apache, and right now we are using NIO on the engine side and async core on VDSM side to communicate. Let's move on to the protocol details. So at this slide, you can see the details how the messages looks like, actually the payload of the messages. So we have decided to use Jsonrpc version 2.0. And from the request perspective, we need to send the method that we want to invoke, parameters, and the ID. ID is used to figure out which actually to correlate requests and responses. And responses contain the content, the result of the invocation. As well, there is a error response, which contains code and message details. Please take a look that all of the messages contain the ID, which is really important to correlate the messages. Next, I would like to cover STOMP details. So the protocol itself that we are using, when we send the initial message, actually the initial message is connect, and the connect itself contains headers. In them, there's information about the heartbeat that the client is willing to get, as well the heartbeat that the client is willing to send. As a reply in connected frame, the other side actually responds with the values that is able to do in the same way. Next, client may send the subscribe. Subscribe is required to receive messages. So the client subscribes to a particular topic, and then can receive messages once someone will send a message to that topic. Next frame is send frame. Actually, this is information exchange. So this is the main feature of the protocol. So the send message is the request, and the message is the response. The clients can unsubscribe and disconnect. As you can see, all of the most of the messages can get acknowledgement, response, or error, except of the connect, which have to have the connected. And when we disconnect, there is no guarantee by the protocol spec to receive the response from the other side. Let's take a look how to actually configure protocol. So on the left-hand side, you can see an XML that you can send over the REST API to the engine while we are creating the new host. And in protocol tag, you can specify XML or STOMP to use one or the other protocol. As well, on the right-hand side, you can see the screenshot from the UI. And in advanced properties, there is use JSON protocol checkbox. So when the checkbox is marked, you're using JSON, and the otherwise you're using XML. Are there any questions about the protocol details? Okay, so let's cover engine implementation. At this slide, this is brief brief overview of how the classes are structured from the engine perspective. So the main I/O loop is reactor. So all of the I/O events are generated by reactor. We have Jsonrpc client, which actually holds the reactor client, and we have two implementations for Stomp. One is the plain connection Stomp client, and the second one is SSL Stomp client. There is response worker, which is a single thread for all the connections, and it's responsible actually for marshalling the messages. So marshalling the JSON itself. And the feature map is quite interesting idea that I'm going to cover later on, but I would like to briefly mention about it. So the engine communicates with the VDSM in a synchronous way, and all of the responses are represented as maps. So at this stage, the Jsonrpc implementation is asynchronous. So when the engine sends the message, we do not wait for a response, and we hand over the future map, which is not populated map. And if the client actually is willing to get the value of the response, if the response is not there, it will block, and if the response is there, it will get the response. So in that way, we can mitigate the waiting time for the response. Over here, you can see how to extend the API. In order to do so, we need to add additional methods to one of the interfaces, depending on which one you are going to use, whether it's VDS or IRS, and then add the implementation in that method in one of the implementation of the above interfaces. And you can see the sample code, which is actually a storage pool disconnect. You can call with parameter to get to provide parameters, and then you build the future map. And over here is very important thing to notice is that status only report for xmlrpc. We wanted to keep the interfaces as they were. Actually consumes the future map, and this is how we make sure that the engine sees the communication synchronous, because the status only return for XML-RPC will always get the values from the map. So that means it will wait for the response to arrive. If that wouldn't be the case, you can pass around the future map, and it will be populated in the meantime. So you won't need to wait for the response. And as a last step, you need to update the XML-RPC implementations as well. Are there any questions? Okay, so let's move on to VDSM implementation. VDSM implementation is quite similar to the engine implementation in brief overview. So we have Stomp Reactor, which is responsible for creating, in this case, listeners. Whenever we start VDSM, we create protocol detector, which actually opens the socket, and whenever the connection is established for that socket, the protocol detector actually will pick the data that arrived, will try to recognize the protocol, and it will pass the socket to proper protocol handler. In this case, on this slide, it will pass to Stomp listener, but it may pass that socket to XML-RPC as well. So from that level, VDSM is agnostic to the protocol that you are talking to. It will detect the protocol by itself, and then it will use proper handler to handle that protocol. As well as you can see, all of the messages are uh, are marshaled, and the bridge is used to call the API from VDSM. And here it is how to extend the API. So the first step that we need to do is to add new verb in api.py. Next, we need to update the definition in VDSM API schema.json to specify what are the values that are coming in and coming out from VDSM. If we are going to send any important replies, we need to update the comment info structure in bridge.py. And for the compatibility, we need to do the same for binding xmlrpc. Are there any questions to VDSM implementation? Okay, so I'm going to talk about the end-to-end flow and how the messages are passed to VDSM and back, and how actually what is the life cycle of the objects for Jsonrpc. So one of the communication interfaces actually creates a client using the reactor. So the client is created, and it is registered in response worker, which is responsible for marshalling of the messages, as I mentioned. And when we invoke a command, we send the connect frame to protocol detector. And at this stage, protocol detector will realize that this is the stump protocol. So it will ask stump reactor to create a listener. The listener will set the handler, and at this stage, we'll send the message, actually the real payload, to the other side. So stump listener will take that and will propagate that call through the bridge to the API. API actually will invoke the business logic on VDSM side, and the response will come back. It is very important to notice that there is no wait from the engine side, so the future map will be returned. And once the response arrives, the response worker will actually marshal the message and then return it to the communication interface, which will actually at the end populate the future map. Are there any questions about the end-to-end flow? Okay, so here are the future plans, what we are going to implement later on. So, as I mentioned, the protocol change from XMLRPC to JSONRPC actually will enable us to implement notifications. In that way, we can push information from VDSM side to the engine, so there won't be any need for polling of the information. Maybe only in critical situations like failures. We just, after some timeout, we need to check whether actually the task is still in progress, whether the VDSM crashed or something. But overall, we can statistics and other data, long-lasting tasks, and the statuses of those tasks we can push to VDSM. I talked about that the implementation is protocol agnostic, and we are planning on implementing IMQP 1.0 protocol. So underneath, we can use the IMQP as well as Stomp using the same abstractions, and on the side we have still xmlrpc. There is a idea to actually implement the messaging broker, which will actually enable routing of the messages. So from that side, not only engine VDSM can communicate using the Jsonrpc, but for example, VDSM internal components can use messaging to talk to each other. We are planning on implementing the compression of the Jsonrpc messages. As well, later on, we are planning to phase out the xmlrpc implementation. So the only protocol, actually, the only abstractions that we are going to use will be the Jsonrpc abstractions, and the protocol underneath will be Stomp and JSON and IMQP or something else if we'll decide to use it. Are there any questions about future plans? Okay, I have one question. How does change affect us developers in the project? Do we need to do anything differently when creating new entries in the engine to VDSM API, when changing existing verbs parameters? So as I said, as I said in one of the slides, let me find that slide for you. So from the engine side, if we change anything, we need to perform those steps, like to add the new method on the interfaces or one of the interfaces, provide the implementation, and for the VDSM implementation, we need to add the new implementation. In order that if we are not adding additional APIs, there is no need to change anything. The Jsonrpc is using exactly the same port as XMLRPC, so no changes required from that perspective. Not sure whether I have answered the question. Are there any more questions about the implementation or differences, or how that influences the developers? If not, so thank you very much for listening, and here are the details how you can contact me. Oh, there may be an additional question. Can external agents other than VDSM use the same messaging broker to communicate to the engine? To be honest, yes, that's the idea, to enable other parts to use the broker. So that's the idea. So there is a way to make sure people don't forget to implement the JSON part. Yes, that's the way is the unit tests, and coverage between the XML or JSON-RPC. So from the engine perspective, you will have actually compile time error, and from VDSM, we just need to make sure that it works. Okay, additional question. When do we plan to implement migration over JSON RPC? So that's actually plans for this release. Hopefully we'll have the migration and we can get rid of the xmlrpc implementation. But this is one of the main steps that we need to achieve before we'll phase out xmlrpc actually to implement migration. Are there any more questions? Okay, one more. When do we plan to support migration? Yes, that's correct. 3.6. So that's the next release. So thank you very much. I mean this. When I say this, I mean 3.6. The 3.5. This is the I described the effort for 3.5. Okay, so thank you very much for listening. If you have any questions, please don't hesitate to contact me. So thank you very much.